This is section 3.4, part 2. We left off with example 1. So a company makes S pairs of skis and B snowboards under the following constraints. So my system of inequalities, called constraints when you're in linear programming, S has to be greater than or equal to 0. So we need to graph that. The variable that we're talking about first is going to be our x-axis, if you will. So this will be my s-axis, and this will be my b-axis. So if this were x is equal to 0, we would draw that as a vertical line at 0. Well, we still have to draw it as a vertical line. We're just calling it s instead of x. So we have a vertical line at 0. We have to be greater than or equal to 0. So if you do your test point, if you go through the point 0, 0, you cannot use 0, 0 as a test point. So pick something else, maybe 8, 0 or something. And you find you're going to be shading in this direction when you do your test point. B has to be greater than or equal to 8, so that is going to be a horizontal line at 8, and you would shade up. Again, use the test point. Now graphing these two, they are in standard form, so when you're graphing in standard form, you have to use your x, y chart, but they're not x and y anymore. So we have our S, B chart. So I'm going to take 0, and I'm going to plug it in for S. So I have 2 times 0, so I'm doing this one right now, plus B is equal to 40. Now remember, when you're trying to find points, trying to actually find the points themselves, you're going to use equal to. If I'm using a test point where I plug in 0 and 0 at the same time, that's when you use less than or equal to. So 2 times 0 is 0. We have B equals 40. And I'm going to plug in, so we need 2 points. So that means we have to plug in 2 different values, 2 different times. And since 0 is the easiest number to plug in, this time we're going to plug in 0 again, but instead of plugging it in for S, we're going to use B. Plus 0 we don't need. We have 2S is equal to 40. Divide by 2, and you get those 2 points, 0, 40. 0, 40 is up here. And what's the other one? 20, 0. 20, 0 is right here. So when I draw that line right there, okay? So this was my 2S plus B was, I don't remember, less than or equal to 40. Less than or equal to 40. That was this line right here. Okay, pick our test point. And I realize it's already graphed for us, but just want to remind you how to graph inequalities in case you've forgotten. So that's why I'm going over it. So test point, since it does not go through 0, 0, we're going to use 0, 0 as our test point. Plug in 0 and 0 at the same time. So 2 times 0 plus 0. Is that true or false? So simplify the left side. I get 0 is less than or equal to 40, which is true. Since my test point is over here and it was true, you're going to shade in the direction of the test point. And finally, the last inequality. Oh, let's use green here. This one right here. Again, it is in standard form. You're going to plug in 0 for S right here. 0 plus B equal 32. We don't need the 0. B is equal to 32. Repeat the process because we need 2 points. You're going to plug in 0 for B. So S plus 0 is equal to 32. You don't need the 0. We get S is equal to 32. Those are 2 points, 0, 32, and 32, 0, which are going to be out one's right here, 32, 0, and 0, 32. So this was my s plus b. Was it less than or equal to 32? Yes. All right. And this was, what was this one? B has to be greater than or equal to 8. And this one was s has to be greater than or equal to 0. That's this one right here. I should probably label it down here. S has to be greater than or equal to 0. All right, so this gives us a shaded region called a feasible region. What we're looking for are the corners. If I have 1, 2, 3, 4 sides, that means I need 1, 2, 3, 4 vertices. Now, some of these vertices are easier to find than others, but what we're doing is we're solving a system of equations. Remember, a system of equations, that's where two lines cross. Well, that's what we need to know. Where do these two lines cross? What point is that exactly? Do not look at the graph and say, oh, it looks like it's about. No, that's not good enough. We need to know that exact point, and the only way you can do that is with algebra, by plugging numbers in. All right, so we need to find out where s equals 0 crosses with b equals 8. So here's my s equals 0, and here's my b equals 8. Well, it crosses at that point right there, which should be pretty obvious that it's the point 0, 8. Okay, so s is equal to 0. S is equal to 0. And 2s plus b equals 40. So that's this one. Well, they cross up here, which is not one of our vertices. It's not part of our corners, not one of our corners of this shaded region. So I don't need, oops, went the wrong way. I don't need this one because it's not one of our corners. It's not one of our vertices. So s equals 0, s plus b equals 32. S is equal to 0. S plus b equals 32. That does cross right there. That is one of the corners that we are concerned with. Well, s is 0. We know that one. So if I take 0 and I plug it in for s, I get 0 plus b is equal to 32, or b is equal to 32. So I've got 2 of the 4 points. Now let's look at this one. We have b equals 8, 2s plus b equals 40. That's b equals 8. And 2s plus b equals 40. Yeah, that one. Okay. So that's these two lines right here, which is one of the vertices we're interested in. So b is equal to 8. So we're going to substitute 8. 2s plus 8 equals 40. And you're going to solve that for s. And that's not a 5, that's an s. I know my 5s look like s's. My s's looks like 5. So this is 2s. It's an s. Plus 8 equals 40. So 2s is equal to 32. And divide by 2. And you get s is equal to 16. Okay. So we need that point. That is part of our feasible region. b equals 8, s plus b equals 32. This is my s plus b equals 32, b equals 8. They cross out here. That is not one of the points we're interested in. Okay, so we don't have to worry about this point. So we don't need this one. And since we need 4 points, 4 sides, we need 4 points, the last one must be, so we must need this one. So let's take a look at this one right there. And that one's going to be a little bit more work. So we have 2s plus b equals 40, and we have a system of equations. We got 2 equations. We need to figure out where those 2 lines cross. You can either use substitution or you can use linear combination. It really is kind of set up for linear combination. So remember linear combination, that's where you add the s's, you add the b's, you add the constants. But if I were to add the s's now, I would have 3s, I would have 2b. Notice nothing canceled out, so that's not going to work. What we need to do is figure out what we can eliminate. So I think maybe we'll eliminate the s. It doesn't really matter. We can eliminate the s or the b. It doesn't matter. So let's eliminate the s. And in order to do that, if this is a positive 2, then this needs to be a negative 2. And for that to be a negative 2, we have to multiply the equation by negative 2. So multiply the bottom one by negative 2, multiply by negative 2, multiply by negative 2. I'm just rewriting the top one because we're not multiplying by anything, but the bottom one we do have to multiply. So negative 2 times s gives me negative 2s. Negative 2 times b gives me negative 2b. And negative 2 times 32 gives me negative, what, 64. And now I'm going to add these two equations together. My s's will cancel out. If I add the b's, I get negative b equals negative 24. The b does need to be positive. Divide by negative 1. And you get b is equal to 24. So my b is equal to 24. I need to figure out what the s is. So I'm going to put 24 either in the top equation or the bottom one. I'll probably do the bottom one, smaller numbers. So I'm going to put 24 in here and solve that. S plus 24 is equal to 32. Subtract 24. And what is that? 6, 7, 8. So I get s is equal to 8. So these are my 4 points, 0, 8, 0, 32, 0, 8, 0, 32, 16, 8, and what's the last one? 8, 24. Okay, so these are my 4 points. Those are the only 4 points I have to plug into my objective function. So let's, well, I don't remember what the objective function was. I'm not sure we actually had an objective function yet. Here we go. Aha. So it says find the maximum profit for the company if they sell the skis for $70 per pair. Whenever it says per, that means multiply times the variable. So skis, that was S, and it's $70 per pair. Okay? When it says per, you got to multiply times the variable. Plus, snowboards are $50 each. So that's $50 per snowboard. So my profit function is 70s plus 50b. And let's see it. 70s plus 50b. Now we have to take each of these points, plug them into our profit function, and we're trying to find the maximum value of the function. We're trying to find the largest p. So I'm going to take 0. So p is equal to 70 times 0 plus 50 times 8. And what does that give me? I don't know. What does that give me? It gives me 400. So this will give me a profit of $400. I'm going to do the same thing for each of the points. 70 times 0 plus 50 times 32. Gives me 1,600. Anytime we can make more profit, that's better. So 1,600 is looking better than the 400. Let's see what 16.8 gives us. 70 times 16 plus 50 times 8. 1520, that's not as good as the 1600, so probably not that one. And finally, the last one, 70 times 8, and 50 times 24. And let's see what that gets. $17.60. Okay, so maximum value. We're looking at these numbers right here. Which one is the biggest? The biggest is 1760. So we have a maximum value of 1760. And this occurs when S, this was this point right here. So S was 8 and B was 24. All right, one problem and it took me 16 minutes. And yes, they will take you at least that long. All right, that's the end of part 2.